So I want to pick up where we left off. A little bit different though is I want for us to actually keep working on those questions that are written so that we can see the questions in any format that they may come across in. You want to be comfortable with what a question is asking, and a big part of that is seeing how they can be written. So here's a question that should work. It says, given that x minus 2 is a factor of k of x, which is equal to 2x cubed minus 5x squared plus x plus 2, factorize k of x completely. No, it's a polynomial division question. We can actually work this if we have an understanding of remainder theorem. But again, we're leading into remainder theorem. So our very first step is to understand what we're being asked, right? No, they start off by saying that x minus 2 is a factor. So if x minus 2 is a factor of, and let me see if I can get this to show as usual. Let's see if we can get this working really quickly. All right, so we said we'll have 2x cubed minus 5x squared plus x plus 2, and that's being divided here by this divisor, and we're being told that it's a factor of the dividend. What does that mean? Well, that means that we're going to get an answer, whatever that answer is, and our remainder, because this is a factor, is 0. All right, so effectively we could literally say that 2x cubed minus 5x squared plus x plus 2 is equal to whatever our answer is times our divisor. And this section over here is actually the factorization that we want, right? It's another way that we can write our dividend as a product of the divisor and the quotient, because of course the divisor x minus 2 is a factor of our dividend. All right, now that being said, let's make some space and let's see what the division looks like, because we know the process, right? We've done the long division before and we're comfortable dividing. So let's write it out. Our dividend being 2x cubed minus 5x squared plus x plus 2. And you guys are veterans by now. This process is straightforward for you. So we're going through the motions here, right? We're going to start by dividing through by our leading term in x, which is x here. And x divides 2x cubed to just give us 2x squared. Now we're good, right? Now our next step immediately thereafter is to subtract, because we're going to multiply our partial quotient by our divisor. So x multiplies 2x squared to give us 2x cubed, and negative 2 multiplies 2x squared to give us negative 4x squared. We're going to put in place values, placeholders for terms in x and or constant, and then we can subtract in that way in line, right? So we have 2x cubed minus 2x cubed gives us 0. Negative 5x squared minus and negative 4x squared is going to give us negative 5x squared plus 4x squared, which is going to leave us with negative x squared. We're going to say x minus 0x is just a positive x, and 2 minus 0 is just going to be a positive 2, right? And we start the process all over again. X divides negative x squared to give us negative x, and we're going to multiply through now by our divisor. All right, so x multiplies negative x to give us negative x squared, and we're comfortable there. Negative 2 multiplies negative x to give us positive 2x, still comfortable. And we don't have a term in or a constant, so we're going to just add a 0 there. I'm going to subtract in line. So negative x squared minus a negative x squared is negative x squared plus x squared. X minus a 2x is just negative x, and 2 minus 0 is just our positive 2. We're almost done with this portion, right? We're going to say x divides negative x to give us negative 1. We're about to finish this process off, because x multiplies negative 1 to give you negative x, and negative 2 multiplies negative 1 to give you positive 2. We get negative x minus a negative x, which is negative x plus x. And we get 2 minus 2. And this basically follows up on what we'd said before, right? Because we know we weren't going to get a remainder that started with the statement being x minus 2 is a factor of our dividend. And so we did not expect a remainder. Getting a remainder at this point would be assigned to you to say, hey, I did something wrong. I need to check because my remainder has to be 0. All right. Now, that being said, what does the rest of our process look like? Let's shift this up a bit. Can we just write our answer now? And in part, we can. We could literally say 2x cubed minus 5x squared plus x plus 2 is equal to our divisor times our complete quotient, which is 2x squared minus x minus 1. And in a question like this that's worth about 3 marks, I would give you 2, because you'd have gone through factorization and you'd have looked at that quadratic and something would have said to you, because I trust you, something would have said to you, I can factorize that. It better say that to you. You need to be able to notice that you can factorize. Always go as far as you can go, because the operative term in that question was factorize completely. Completely means if you stop right here, you're not getting full marks. So let's factorize. No. If I have 2x squared minus x minus 1, how do I factorize that? Now, this one you should know, but let's assume that you don't know. The idea is here that when you started factorization in general, you always would get 4 terms. And you would factor those 4 terms, and you'd look for what is common to each pair of terms, and you'd factor that out, right? And that was light work for you. You did that was straightforward. But then you got to quadratics, and we're factorizing by grouping before, had 4 terms. Quadratics, as you can see, have only 3. And because that's the case, did I just put something there? Okay. Because that's the case, our goal is to rewrite our quadratic as a 4-term expression. Oops, and this should be a minus 1, but yet I have plus. Let me correct that if I can quickly. All right. I know you're bearing with me. You're very comfortable now with technological issues working with me on this thing. So this is almost second nature at this point, right? All right, these things happen. But I know you're comfortable, so I'm comfortable. All right, so let's finish this up. So the idea is, what 2 terms do I put here? Now, I can't just put any 2 random terms. These 2 terms have to sum to negative x. So do I use negative 5x and positive 4x? Do I use negative 7x and positive 6? What do I use? Well, what you want to use is you want 2 terms that have something in common with both the coefficient here and the constant here, right? And to figure out what that is, we can multiply them both. So 2 times our negative 1 is going to give us negative 2. And I want the factors of negative 2, right, that sum to negative 1. So I can replace a single term with 2 of them. So I could use negative 2 times a positive 1, right? That works. So instead of having here 2x squared minus x minus 1 being equal to just 2x squared and any random term, I'm going to put minus 2x plus x minus 1. And in that way, I haven't changed the value of my quadratic, because these 2 terms sum to negative x, right? But I can now factor by grouping, and it doesn't matter which one of these 2 terms I put first, because the terms both have something in common with the coefficient here and the constant here, right? So let's factor, and let's give ourselves some space as usual. Scroll up a bit. We're almost there. I know it seems like a lot of work, but again, we're explaining, and because we're explaining, it takes a bit more time. Let me scroll down a bit. All right, we should be okay here, right? So what we end up with is what is common here, because we're going to factor by grouping. And I can factor out a 2x, and that leaves a x here. Factor 2x out to negative 2x, I get a negative 1. By right, because of the method that we've used, what is factored here will also be factored over here. But I am going to just factor by error. What is common to x and negative 1 would be just positive 1. And what remains is x minus 1 as the factorization of this binomial. You'll have 1 times x minus 1, and the factorization of this binomial will be 2x times x minus 1. Right? And now when we look at these 2 terms, what is common here is this one and this one. Same thing. So I can factor out x minus 1 to just leave 2x plus 1. So what does that mean for my answer that I had, where I had 2x cubed minus 5x squared plus x plus 2 being equal to that divisor of x minus 2 times that quotient of 2x squared minus x minus 1. Well, I can rewrite this as a completely factored x minus 2 times x minus 1 times 2x plus 1. And that would be our factorization. This is a completed factorization. That's my 3 marks. And I mean, it could be more than 3 marks on a question like this, but because it's basic polynomial division, it's likely to be somewhere around 3 to 4 marks. So that would be the answer that would be expected. That's what we'd expect from you. And so I hope that you keep on practicing, continue to, follow through with us. And, if you have questions, you can always send them in comments. I'll take a look, see what we can walk through, what we can talk about. But until then, don't forget to like and subscribe.